sitting there with a ruler all day long trying to line those up and saying this is where it goes. Well, no, we don't need to do that. They've got this view. The only thing they need is depth. They need to know if these holes are blind holes or through holes. That's all they really need. So we just give them that information. Again, this one's on a quadrant point. Here we don't have to revolve anything. This one's on a quadrant point. We don't have to revolve it, but we're going to use the revolve convention and not show all this misleading views that are through here. These foreshortened surfaces. There's one more example that the author gives you. Here's one again, same distance from the center on all these. This is quite a misleading view.
Yeah.
Okay. Looks like, why is this down here, you know? And they forget to look at stuff. Okay, so what we'll do is we'll just take this guy, we'll rotate it down to the quadrant point. They now have the true distance from center to center displayed in that view. So again, we're trying to clarify these drawings, is what we're trying to do. So the revolve convention, revolving spokes, holes, things of that nature to the quadrant points and projecting as if that's their location.
Do you show that on this drawing?
Not necessary.
You don't need to, because
No.
that infers that it moves like that one moves.
Mhm.
So you don't, that's just for our,
That's for you in the textbook, yes. This would not be displayed on your drawing.
but
It
you're
would
gonna have to
be
calculate,
this
you're gonna have to
view,
know that to do that one.
it'd be this view and this one.
Okay.
And they're gonna see, you know, they're gonna say, oh, that doesn't line up. Oh, they took that and rotated it down. All these other programs out here, they do blueprint reading. And they're supposed to be going over this stuff. Whether they do or not is up to them, but they'll find out when they hit industry very quickly what these are.
So do you draw the object when it's at rest? Like if the object moves, do you draw it where it would rest? Does that make
That's-
sense?
was that my question?
I'm not sure I understand your question.
So like how that handle moves and everything, you draw it where it's facing down because that's,
It doesn't move.
It doesn't move.
It doesn't move. That was my question. That was just, I mean, that piece doesn't, if you drew that, that implies that it does. That's just for our use showing how they project it over.
Yeah, this would not be
That's
on
why I
your
just said,
drawing,
that's not being drawn. That's just for us to understand it.
what they're
that's
doing.
very
yes.
confusing.
Yeah.
This is not on your drawing.
Okay.
Just
That's
the
why,
object
that's
lines
exactly
are.
what I just asked. Yeah, that's.
Yeah, just the object lines are on your drawing. Now, if we had just one of these, now this thing rotates about the center.
Yeah.
All of these move. Now, if we had just one of them that moved, then you would pull out your phantom line and say, this guy moves to this location. I wouldn't use a partial convention at that point because I'm just dealing with one different deal. The object's got too much complexity for me to do that.
Okay.
This is for these objects that are all about a center. The revolve convention. Revolve your spokes, your wheels, your bolt holes to the quadrant locations and project as if that's their true location. Keep in mind, they still get that front view. So they'll have the spacing and orientation. Are we okay to leave this one?
Yes.
Okay. The next one's the one you're going to do the most of. In fact, this will be a majority of your drawing in many disciplines. By this, the civil, the structural, the architectural worlds, they live with this convention. It's called a removed convention. What we do with a removed convention, again, let me just put my definition up here. Parts of an object are moved and drawn at a larger scale. Parts of an object are removed and drawn at a larger scale. Okay, we'll start with 1088. This gives the example. By the way, when we do a removed convention, these are called sections, they're called details, they're called a bunch of different things. So the two pop in my mind right now, details being what we call them normally. So in essence, we give them the multi-view. Okay? So front view, top view. Now on this one, the thing they wanted to do was we had to show this at this scale to do this, but now we have a little tiny area right here. There's no way you can see this thing at this scale. And so what they've gone and done is they put a phantom line characteristic circle with a letter. This is an identification letter. This is actually what we call a cutting plane. So this is a very thick line, phantom characteristics. What this is saying is that we're going to do a removed view around this circle, and we're going to blow it up for you so you can see what's going on here. So what a person would do is then say, oh, I got to go look for view A. And they come over and they find it. Here the scale has been enlarged, and now we can see that there's a little hole in here, and this is how we're joining these two pieces of metal together, is we're going to bolt them. Think of footings. I mean, you go back and look through that drawing set on that table behind Gabe, and there are sheets and sheets and sheets and sheets of these things. Because it's really how we get to the level where things are built. Think of door headers, door frames, how we're putting the carpet on the floor, where does the rebar go in, the cement down there. All of those are done with details. But these are, without a doubt, the most drawing you will do. Okay. So a removed. Now, you'll see a lot of different nomenclatures. This one's got just an A, so this is going to appear very close to us. You will see other ones that have like this in it, and you might have a 1 and a 4, or you might have an A and a 3. And always this top one is the identifier. And the bottom one is the page you're going to find it. So if you get a really big set that's broken out, correct, this bottom one might even say you're going to go to C-3.2 or 3.1. And that will give the page number that you can find this detail on. Okay, there's your three conventions. So you have a partial. Parts of the object are not shown to aid in clarity due to a confusing projection. Really works really well on symmetrical objects and objects that provide confusing views. You have the revolved convention, where you take circular objects about a center, you revolve them to the quadrant points, so you remove the foreshortened projections of those objects. And then you have the partial, where you don't have sufficient detail at the scale you're printing for people to see stuff, so you remove portions, enlarge the scale to show them that information. These are available for you to pull out on all your drawings. Okay, so right now we have the glass box, shows us how to project multi-views. You have 3 more things in your toolbox now. So if you pull that projection and you got hundreds of lines sitting on that thing, and you drew it and you understand it, and you look at it 3 hours later and you say, I can't understand this. Well, that's probably a pretty good indicator you need to go do something different. Okay? Okay, how can I make this easier for the person downstream of me? That's what these are about. Okay? All right, that's it for chapter 10. Tomorrow we'll do a review on this chapter and get ready for the test on Wednesday. Are there any questions on what we talked about?
Is the exam just over chapter 10?
10 only. Well, I shouldn't say that. I'm going to have a couple things off of chapter 5. Let's see, G3 was due Friday. Did everybody get that print? I know we